Powertools for AWS Lambda .NET Tracing Library is an opinionated wrapper for AWS X-Ray aimed to reduce the overhead of performing common tracing tasks. Some of the key features that Powertools provides for tracing include attribute-based tracing, helper methods to easily add annotations and metadata for the trace segments, capture function responses including exceptions, etc. In this video, let's learn how to get started using the Powertools for Lambda .NET Tracing Library when building Lambda functions in .NET. Hello everyone, my name is Rahul and welcome back to this YouTube channel. If you're new here, I make videos around .NET, Cloud and DevOps. This video is sponsored by AWS and is part of my .NET on AWS series. So without much delay, let's get straight into learning more about Powertools for Lambda Tracing Library. Powertools for AWS Lambda is a set of utilities that are useful when building Lambda functions, and it helps us to adopt good practices for tracing, logging, custom metrics, etc. In this video, we will learn about the tracing functionality that this Powertools library provides for us. It makes tracing to AWS X-Ray very easy and with very minimal code from our side. To see this in action, let's switch over to Visual Studio, where I have an existing AWS Lambda function in .NET created. Now this has the default functions class, where we will be starting to add the tracing library support. To do this, let's first build up this Lambda function. We will use the Lambda Annotations framework, which allows us to easily build an API endpoint using this framework. If you're completely new to Lambda Annotations, I highly recommend checking out my video, which is linked here, which will help you get started. All we need to do to use Lambda Annotations is again to add a couple of NuGet packages. So let's go into the Solution Explorer, right-click and say Manage NuGet Packages. So let's search for the Lambda Annotations library first. So let's search Lambda Annotations and let's install the amazon.lambda.annotations NuGet package. So let's first install that. Let's also search for the Lambda API gateway because I will be building an API endpoint. And let's add the amazon.lambda API gateway events library as well. This has the required classes to handle API gateway requests and responses. Now to install the Powertools Lambda, let's search for the Powertools Lambda Tracing. So let's search for Powertools Tracing. Here we have the AWS Lambda.powertools.tracing NuGet package. So let's add that as well. So once we have these three NuGet packages installed, let's come back to our function class and start using this tracing library. Now to make this function endpoint as an API endpoint using the annotations library, all I need to do is wrap it with the Lambda function attribute. So let's call this as Lambda function. Specify use amazon.lambda.annotations namespace. Let's also specify as this is going to be an HTTP API endpoint. And let's say this is a Lambda method get. And let's also specify a route in here. So let's specify this route gets in a city name. So let's specify the city name as a parameter. And let's change this input to be city name. Now all this endpoint is, it's a get endpoint, which takes in a city name parameter. Now let's say this endpoint is going to return a list of weather forecast data for this given city. So let's create a new class in here, call this as weather forecast, and I have a few properties already defined. So it has the city name, the date, and a temperature for that particular city. Now if you want, I can move this to a different class. So let's specify move type to weatherforecast.cs. So that moves it into a new class in here. Now for the city name, let's generate some dummy data. So let's return here, new list of weather forecast data, and let's create a dummy data in here. So let's create a new weather forecast. Let's specify the city name is equal to whatever the city name that we have passed in, so that matches. Let's also specify the date. So let's leave it as datetime.now, and let's specify the temperature as a random value. So let's specify random.shared, and let's create next and specify a value between -10 and 40. So given a city, it's going to create a random value between this and return a list in here. Now this list is only having one item for now, but we are good with that. Now let's change the return type to be a list of weather forecast, and let's also make sure to close the braces appropriately. So let's make sure to format this Now by adding in these two attributes, it has automatically created a serverless.template file which will allow us to deploy this Lambda function. This is all part of the annotations framework. Now to start using tracing for this function, all we need to do is just add the tracing attribute, which again comes from the AWS Lambda.Powertools.tracing NuGet package. Now just by adding this, we have enabled tracing for this Lambda function. Now, however, for tracing to work, this Lambda function needs access to write to the AWS CloudWatch logs and also to X-Ray. So for that, let's specify the specific policies for this Lambda function when it will be deployed. So for that, on the Lambda function attribute, we can specify policies and pass in a known list of policies in here. So we can pass in the AWS X-Ray daemon write access and also the AWS Lambda basic execution role. Now these two policies will allow us this Lambda function to write to X-Ray and also to the CloudWatch logs. Now once both of them are set up, let's switch over to the serverless.template and expand this, and you can see the appropriate policies are set on the Lambda function. So let's right click on the project in Solution Explorer and say publish to AWS Lambda. Now this prompts the deployment window, and here we can specify a stack name. So let's call this as the weather API, and let's deploy this to this S3 bucket from where it will be deployed as an AWS stack. So let's click publish. So this is currently uploading it, and once that is done, you can see the stack creation progress. Now this is currently creating the new stack and the API functions and also the Lambda functions inside that. The stack creation is complete, and you can see the serverless URL right in here. So if we click this, it navigates to the browser and you can see the dummy data coming back. Now right now the city name is empty. So if I pass in a city name, let's specify Brisbane, it's going to return a random data for that city. Now if I navigate to my AWS console and navigate to the stacks, you can see the new stack that is created. This is all using the Lambda Annotations framework. Now what we are interested is to see the tracing in action. So let's navigate to the resources and let's go to the Lambda function in here. Now to enable tracing for this Lambda function, we need to go into configuration and under the monitoring and operation tools and enable tracing. So let's click edit and let's turn on add AWS X-Ray active tracing and let's click save. Now this turns on tracing for this Lambda function. You could do this using the CloudFormation template. However, it gets overridden every time you make a change in the function class. Now I'm not sure if there is a way to specify specific attributes using this Lambda function annotations framework. Until then, I will just go into the console and manually turn it on once. Any further deployment that happens to that will keep this tracing flag on. So let's switch back to AWS console, go into the monitor tab, and under traces, you can see any new traces that comes for this Lambda function. So let's switch over to the endpoint, make a few requests in here. So let's specify Brisbane, and also let's specify Sydney and a few other cities. So let's specify London, and let's also specify Mumbai. Now this is all going to return dummy data for us, and let's switch back to the Lambda function and click refresh in this page. Now you can see here, there are the first traces that's coming up in here. There is a certain delay for the traces to show up in the X-ray, but it's not that long. So now you can see all three requests have come here and it shows the appropriate details against that trace. You can also see the service map in here. All this does is the Lambda context calling the Lambda function. So if I scroll down and click into one of these traces, you can see the details for that specific trace. Here we can see that it has the Lambda context, which calls our function handler, and you can also see the individual times and the duration taken for these calls. If you drill into one of these functions, you can see more details on that specific segment. So you can see high level different properties of this particular call and the function call that is being made. Now right now our Lambda function has only one of these function handler methods, because of which we just see one segment inside the trace. Now let's say we move this into a helper method. So let's create a new method, let's say extract method, and let's specify generate dummy data, and let's just return that. Now in this case, this is calling into a separate function in itself. So let's attribute this as well to enable tracing. So let's specify tracing for this method as well. Now this is going to automatically create a subsegment inside this main segment of the function. So as many function calls that you have with this tracing attribute, all of them are going to come as segments and subsegments. You can also manually create a subsegment. So let's specify the tracing class and let's specify the with subsegment method. Let's say this is going to be a separate subsegment. So let's specify generate dummy subsegment. And we can specify a function inside here, which is going to return the data or do any other processes. So in this case, let's simply add a task.delay and let's specify which is 1000 milliseconds. So let's also make sure to add a wait call inside this. So let's make sure to async await this. So let's add in the async and let's specify await as well. Now, since this is async, let's make the whole function async as well. So let's specify this as async. And let's specify the return type as a task of list weather forecast. Now we don't want this function to be static, so I removed that as well. So let's update this function as well to be asynchronous. And let's make sure to add the await keyword. Now the with subsegment takes in an action. So let's remove this parameters and let's simply specify an underscore, and this now compiles perfectly. So now we have added two subsegments into this main function call. So let's see this in action. So let's build this and let's make sure to publish this to our AWS Lambda. So let's right click and let's say publish to AWS Lambda and click publish. So this uploads the new package to the AWS console and it deploys it to the Lambda function. Fast forwarding in time, we have the deploy complete and it's all successful. So let's navigate back to the console. Let's go to our API endpoint and let's make a few more requests. Let's also change the city to be Brisbane. So we have some requests that's being made. And now let's switch back to our CloudWatch logs and let's go back into the main segment where we can see all the traces for this Lambda function. And let's refresh this page. Now here you can see a new record that's coming in here. So let's right click on that and let's scroll down. So in the segments timeline, you can now see there are more subsegments and segments inside this. So we have the function handler, which calls the generate dummy data, which further calls the generate dummy subsegment, which we manually created using the tracing class. You can also see the full details of these subsegments inside here. Now that we know how to add segments and subsegments to these traces, let's see how we can add annotations and metadata for our traces. Now, annotations and metadata are additional information about requests, the environment, or the application in itself that you can capture as part of these segments and subsegments. Now, annotations are key value pairs with string number or Boolean values. With annotations, they are indexed and can be used in the filter expressions. Metadata again are the same key value pairs, but these are not indexed, which means you cannot use them to filter in queries. So let's see how we can add these in our functions. So let's switch back to Visual Studio. Now to add an annotation for this main function, all we need to do is call the tracing library and call the add annotations method. Now in here we can specify the key and the value. So let's specify the city as the key and let's specify the value as city name. Now this is going to create the annotation record with this specific key value. Now you can also create a metadata inside here. So let's say this is going to be where results. Let's return the results. But before that, let's also add a metadata. So let's specify tracing.add metadata and let's specify the weather count as the metadata. So let's say results.count in here. Now this is going to add metadata and annotations for this endpoint. So let's make sure to save and deploy this function. So let's right click, publish to Lambda and click publish again. With the magic of video editing, we have the deploy all done and complete. So let's switch back. Let's go to our endpoint and let's make a new request. So let's specify Brisbane. Let's specify Sydney. Let's make a couple of calls for this. And let's also make a call for Mumbai. So this has made a couple of requests. So let's switch back to the AWS Lambda function traces. So let's navigate back to AWS Lambda function. So let's navigate to the latest trace information. Let's scroll down. And here in the function handler, let's go into annotations and you can see the annotations city name that we've added. So this has the city as Mumbai. If you switch over to metadata, you can also see the metadata information, which is the weather count. You can also see the response, which is automatically logged by the tracing library. You can turn this off if you don't want the response to come inside this metadata section. Now, if I navigate back into the traces list, I can start using these annotations to filter these traces. Now, to find a query, you can go into the queries and you can see some samples here. So in here, you can query using the annotations. So let's specify annotation.city is equal to Brisbane. And let's run this query. Now this shows only the segments that has this specific annotation. So it shows up one record. So if I query it for another one, so let's specify Mumbai and run the query, this is going to show two records. So let's navigate into one of them and you can go into the function handler and see that this annotations is for the city Mumbai. So using annotations, you can further filter down these traces to the specific traces that you are interested in. Now by default, we saw that the responses were logged inside the tracing. So you can disable this by turning it off using the Powertools tracer, capture response, and the capture error environment variables. This is by default set to true. You can also disable this at the function level. So if I switch back to Visual Studio, for this tracing attribute, we can specify the property capture mode and specify the value that we are interested in. So let's specify the tracing capture mode enumeration, which gives us different values, which includes disabled, and also specify just the error, a response and error, response and environment variable. So you can specify one of these to just capture that specific information. Now, when building AWS Lambda functions, it's very likely to be using external services as well. These may include DynamoDB, Secret Manager, etc. Now, in these cases, we might want to capture the request to these external services as well. This also applies to external API calls that we are making from our application. Now, you can include these into the traces as well. So let's update this function to talk to DynamoDB, for example. So let's go into our NuGet package and let's right click and add the DynamoDB NuGet package. So let's specify manage NuGet packages. Let's go into browse and let's specify DynamoDB and let's add the DynamoDB v2 NuGet package into this function. Now I have the NuGet package installed. So let's go into the function class. Let's create a new constructor and let's create a DynamoDB context. So let's specify the variable as DynamoDB context is equal to new DynamoDB context and let's create this instance. So let's also create the DynamoDB client, which is required to create the DynamoDB context. So once that is created, let's specify this into a variable. So let's create a private read-only property to capture this DynamoDB context. Now to start using this DynamoDB context, let's retrieve the data from a DynamoDB table. So instead of generating this dummy data in here, let's go and fetch this data from our DynamoDB table. So let's make sure to use the tracing attribute as well. So let's copy these first two lines and create a new function for our function class. So let's get this as get data from database. Now this is also having the tracing attribute on, and this needs to return a list of weather forecast. So let's use the DynamoDB context dot query async. Let's specify the table. In this case, this is going to be weather forecast. So let's specify the type name and let's simply specify the city name. So let's pass in the city name in here. Now this is going to return the results for this. So let's specify return. And let's also call the get remaining async so that we return the data from the DynamoDB database. Now, since this is an async, let's make sure to add an await call. So this returns a list from the DynamoDB table weather forecast. Now, if you're completely new to DynamoDB, I highly recommend checking out my video on getting started with DynamoDB, where I'll teach you how to connect with DynamoDB or how this all works. Now, once we have this function, let's switch out this generate dummy data call to the call from get data from database. So let's replace that function. And from now on, it's going to talk to the database and return these data. Now, in this case, this Lambda function needs permissions to talk to this DynamoDB table. Now, I already have a DynamoDB table with the name weather forecast inside my account, because of which I don't have to create a new one. However, I still need access for this function to talk to that. So I have created a new Lambda function role for that inside the CloudFormation template. So let me switch over to serverless.template and let me paste that in under the resources section. So in here, we can paste this, a new Lambda IAM policy role inside of here. Now all this does is create a new type of IAM role. It has the name of Weather API Lambda Execution role, and it specifies the Lambda permissions. Now it also has the managed policy ARNs that we earlier specified, which is the Lambda basic execution role and the X-Ray daemon write access. Now these are explicitly being added in as managed policies. Now I'm also creating a specific policy that I wanted to add, which is giving this Lambda function access to the weather forecast table. And it specifies the all DynamoDB actions and provides this allow effect on that. Now with that policy set up, I can switch up the Lambda function to use this new role instead of these two policies explicitly. So let's remove this and let's specify the role is equal to, and let's specify at and paste in the name of the role. So using at uses this from the CloudFormation template. Now that we have specified the explicit role for this function to talk to DynamoDB, we should be able to capture the request that's going to DynamoDB. So to do that, we can use the tracing library again. So before we make the instance of the DynamoDB context, we can make an additional call on the tracing class. So let's specify register for all services method. Now this defaultly registers the X-Ray for all the instances of Amazon Service Client. Now the DynamoDB client is an instance of the Amazon Service Client, because of which DynamoDB will also get registered. You can also choose to register just individually for the service. To do that, we can specify the register function and we can specify the Amazon DynamoDB interface, and it will just register for that specific interface. But for now, let's keep it for all the services. So any other services that we connect to from here will automatically be registered. Now let's build this and let's deploy this to the Lambda console. So let's right click and say publish to Lambda and click the publish function. Now this time when it updates, it's also going to create the new IAM role inside this deployment process. So let's refresh this, wait for this to complete, and let's see the connection to DynamoDB in action. The deployment is complete, so let's switch back to the browser. Let's go to our endpoint and let's click refresh. Now in this case, it's going to talk to the DynamoDB and return the data. So now you can see there's two records coming up for the city Mumbai, and these are not hard-coded anymore. Now if I use the city as Brisbane, it's going to return the data for Brisbane and also for Sydney and London. So we have all these different data inside our database. So now these would have also created the traces. Let's navigate off to the Lambda function and let's refresh this traces. So let's click the refresh button in here, which should reload the trace information. Now let's specify the custom time to be 15 minutes and just see the data for the last 15 minutes. Now in here, you can see that now this is talking to DynamoDB, and it also shows the weather forecast table inside the service map. So if I was to zoom out, I can see the full picture of this integrations. So it talks to the Lambda function, and this Lambda function further talks to the DynamoDB table. So if I scroll down inside the segments, you can see the information for those segments as well. Now, if you scroll down in the subsegment, you can see now this is going to use the get data from database subsegment. And it also calls the DynamoDB, which is also getting registered in here. So if I select that, you can see the trace information for the DynamoDB calls that this Lambda function makes. So you can see in the resources, it specifies the attributes to get, and it also says the 3 attributes that it is getting. Now, if I navigate back to the function handler, in the annotations, it still has the London, and in the metadata, we have the weather count 3, since I disabled the extra information that's getting logged. So if I switch back, you go to the function class, I had made this to capture only error information, which means the results are not getting logged under the metadata. Now, if you connect with other AWS services like Amazon SQS, SNS, Secrets Manager, etc., all these calls will also be traced in here. You can also trace explicit calls that you make to HTTP clients to come up inside this dashboard. I hope this helps you to get started with the Powertools for Lambda tracing library. We saw how to set this up and how to enable tracing and see this in AWS X-Ray. We also learned how to add segments, subsegments, annotations, and metadata to our trace functions. Integrating with external services is very important when building applications, and we saw how easy it is to see trace information for those external service interactions as well. If you like this video, please make sure to hit the like button. If you want to be notified of future such videos, please make sure to hit the subscribe button. It also helps me to grow this YouTube channel. Thank you and see you soon in the next video.